Hi, everyone, and welcome to this Data plus AI Summit Europe talk on notebook-based AI pipelines with Elyra and Kubeflow. I'm Nick Pentry. I'm a principal engineer at IBM. You can find me at MLNick on Twitter, GitHub, and LinkedIn. I work within a team at IBM called the Center for Open Source Data and AI Technologies, or CODA, where I focus on machine learning. I have a long background in the Apache Spark project, where I'm a committer and PMC member, and I'm author of Machine Learning with Spark. I've talked at various conferences, meetups, and more recently, many online events around the world on topics related to machine learning and data science. Before we begin, a little bit about CODA, or the Center for Open Source Data and AI Technologies. We're a team of over 30 open source developers within IBM, and we aim to effectively improve the enterprise AI lifecycle out in open source. We contribute to and advocate for any projects that are part of IBM's AI offerings and are foundational to those offerings. So this includes Apache Spark as a core component, of course, as well as the Python data science stack, open source projects for open data and model sharing and exchanges, deep learning frameworks, as well as AI ethics and model serving, as well as orchestration on Kubeflow. So today we're going to talk a little bit about that Python data science stack, in particular, Jupyter and a project that we developed within our team called Elyra. So today we'll start with an overview about the machine learning workflow, then talk about Jupyter and Jupyter notebooks and Elyra. We'll give a live demo of some of Elyra's capabilities, and then wrap up with a conclusion. So to begin with, the machine learning workflow typically starts with data. We take that data and we analyze it, we explore it. Typically, in order to use raw data in machine learning, we have to do some kind of pre-processing. We can't just throw that data straight into a machine learning model. It doesn't arrive in a neatly packaged format that is numerical vectors. We need to extract features, do pre-processing, and then get that data into a format that it can be used. We then go through model training, selection. Once you have a trained model, we then deploy it. And that's typically where a lot of the discussion sort of ends. But actually, even once a model is deployed, we need to still do quite a lot of work to maintain that model and monitor the predictions that it makes. And then a model that's out there running in the wild will also be impacting its own data, effectively its own training data, and new data will be arriving. So we kind of complete this workflow and it becomes something of a loop. Now this workflow spans teams. When you talk about data side, that's typically the domain of your data engineers who are responsible for your data storage, providing schemas and managing access, data governance, and so on. This loop or workflow in the middle is the provenance of your data scientists and researchers. So they're typically pulling data into their process, doing the analytics, pre-processing and feature selection and extraction, model training. And then the final team is machine learning engineers and production engineers who are responsible for the production infrastructure who are actually deploying models at scale. There's a lot of potential conflict that comes between these teams, and also a wide variety of tools that are being used. So there's a wide variety of both standard and non-standard data formats for analysis and data visualization, as well as the machine learning and data science toolkits and frameworks. Each team will have typically multiple frameworks and toolkits being used. And every data scientist researcher has their own favorite, and typically all of those need to be supported. And when it comes to deployment, you have, again, a variety of formats and mechanisms, ways of deploying things, and even the languages and infrastructures used for large-scale production deployment is typically quite different from what you have in your data science and research workflows. So there's a lot of potential conflict here, and all these teams need to work across silos and across frameworks. And any production machine learning system typically has to support all of them. Now, a core part of the data science and research workflow is iteration and experimentation. So this happens at each phase in this process. So when data scientists are analyzing data, the data process doesn't just happen once. You don't just go through this workflow of loading, data cleansing, exploration, interpretation, and analysis, and then you're done. Now, typically, what happens is you start with a problem that may be either well-defined, hopefully, if you're lucky, or fairly ill-defined. And that problem is a set of questions that the business needs to answer, or a particular problem or use case that needs to be solved with data. So typically, the data scientists will load the data. It almost never comes in a nice, clean format. There's many disparate data sources. So a lot of data cleansing has to happen. And then you start asking questions of the data. So doing analytics, exploration, computing statistics, aggregations, and creating data visualizations, dashboards, reports that are then interpreted to give an outcome. But typically, either one of few things typically happens. Sometimes one of them, typically most of them. Either the answers that come back themselves create more questions, or potential issues are found in the data itself or in some part of the process. And then you have this effectively iterative process of refining this workflow. So going back to the beginning, maybe fixing some of the data, maybe bringing in more different data sources, adjusting the way that it's cleaned, adjusting the analytics itself. So there's a lot of iterative workflow that happens here. This is similar in the machine learning space, where we follow this process of taking the raw data, extracting features, pre-processing those features into a format that's usable for machine learning, training. And that's typically a model selection process. You don't just train one model. Typically, you're training many different types of models, many different pipelines to try and find the one that fits the best. And then that's the evaluation process, where you're actually evaluating the model on a set of test data based on some metric. And typically, this is also an iterative and process that's heavy on experimentation. Data scientists need to try things out, test out different combinations of parameters, different pre-processing steps, feature extractors, different models, different combinations of all of these things. So this is also a loop where the process and the workflow is constantly refined. So experimentation and iteration are critical, and that's why notebooks, and in particular Jupyter notebooks, have become the de facto standard for this type of workflow, for content-rich interactive work. Now, notebooks bring a wealth of power to the data scientist and to machine learning research into this workflow. But there are some issues with notebooks, and what you typically see happen in this iterative workflow and process is that the notebook, where the initial exploration is happening, grows and grows and grows, and it becomes a monolithic structure that does everything in one place. So it makes it very difficult and increasingly tough to actually extract out pieces of code, functions, create little mini libraries and modularize the code. So it becomes a bit of a behemoth. That makes it a lot more difficult to productionize. So rather than have nicely modular pieces of code or functionality that are connected, you have this one big notebook which can't just be chucked over the wall to production. It's also very difficult to scale up and deploy notebooks in a scalable manner. So to address this and some of these issues, Elyra was created by our team. Elira is a set of AI-centric extensions to JupyterLab. The JupyterLab is an open source notebook environment that is highly extensible, and Elira is a set of these extensions. It's actually named for Elyra, which is one of the moons of Jupiter, and you can see Elyra here is orbiting the Jupiter ecosystem. So we'll go through a couple of the core components and features of Elyra before we actually walk through it in a demo. So one of the most important pieces here is a visual pipeline editor. So we can see here, this is a way to visually build AI and data science pipelines. consisting of both notebooks and Python scripts. So this is a DAG, a directed acyclical graph. It can have multiple input and output nodes effectively, and multiple branching structures. This shows a typical process of loading data, performing some data processing and cleansing, and then splitting into multiple downstream tasks, some of which may be analytics and data science related, some of which may be machine learning related. So the power of Elira is that this one pipeline specification can be run both locally and remotely, allowing you to test things out locally really easily and quickly, but also when the time comes to scale up by running, in this case, and at the moment, on supported platforms such as Kubeflow Pipelines. So there may be more coming down the line and planned. The Kubeflow Pipelines is the main kind of remote workflow executor. This means that once the iterative and experimentation phase is completed locally, the code and set of notebooks can be modularized into a set of notebook modules, which are the nodes in this graph, as well as potentially Python scripts. And these can all be packaged together as a batch job that runs in Kubeflow. So each node is executed in its own isolated container environment and has availability and has access to the full cluster resources. So related to this is the ability to execute single notebooks as batch jobs. And effectively, this is a single node pipeline. And this is also possible for Python scripts. So Python scripts are also first-class citizens. They can be edited within Elyra in the editor and executed against either local or cloud-based resources. There's a few other features such as the automatic generation of the table of contents from the markdown within notebooks based on the heading structure, which allows you to navigate easily between the different headings within your notebook. There's a code snippets module or plugin that allows you to create reusable code snippets across various languages and insert them into your notebooks. And finally, tight integration with Git for tracking project changes. And this allows you to investigate diffs and compare changes, as well as to easily import your remote projects from Git into your Elira workspace. So this means that you can easily share code amongst projects and teammates. So Elira is an open source project. Then there's a few ways to get started. You can either go to Binder and start it with no installation from your web browser. You can use the pre-built Docker containers, or you can install Elira on your local machine. There are the links here to check it out. Okay, so we've gone through some of the highlights and the features, but I think what speaks the loudest is to do a live demo of some of the functionality. Right, so here we see Elira running in JupyterLab, and we can see the JupyterLab launcher has added these components for Elira. You can open a Python file and our pipeline editor. On the left here, we see our file browser. Now, if we have a look at the pipeline editor, this is what it looks like. So we can see we've got a pipeline here that involves loading data from two data sources, processing it, merging it together, and then doing some downstream analytics tasks. In this particular case, we're going to be using two data sets, which are actually hosted on the Data Asset Exchange, which is one of the other projects that is coming from Code. And the Data Asset Exchange, or DAX, is a place where you can find free and open source data sets. We're going to be using two of them, namely the airline flight delay data and the weather data set for the JFK airport. And our aim here is going to be to both analyze flight delays and the potential causes, as well as to try to build a model to see whether we can predict whether a flight will be delayed. The pipeline editor, as we see, can handle both Python script files as well as notebooks. And we have the ability to drag these components around and to create comments for each node. We can then connect nodes to each other, and as we can see here, we can have one-to-one relationships as well as many-to-one and one-to-many relationships. So we can create any kind of DAG structure that we wish. Now, each of these nodes has a set of properties. And we can see here that for example, the runtime image is able to be specified. We're going to use pandas, but you can specify a few pre-built ones that are covering the main frameworks, as well as creating your own. Key here is that this particular script uses an input environment variable where we're specifying the location to download the data, and it creates some output files. Now, we then move on to our data processing, where again, we're going to be specifying a runtime image and some output files that are going to be coming out of this node. Now, the output files are not actually strictly required in local mode, but this output file location is used to make the output of each node available to downstream tasks when you're running on Kubeflow. So after we do some pre-processing and data cleaning, we're then going to merge these two together, these two data sets together. And we're then going to use that merged data set, which combines flight delay data as well as weather data to do some analytics and some predictions. Now, in order to execute, we can just execute this workflow and select whether we want to run it on Kubeflow or locally. So for now, we're just going to execute something locally. And as you can see here, this is our JupyterLab console on the command line. We can see that it's busy executing. So it's going to be downloading its data and executing each of these notebooks. So we can see that in local mode, effectively the data is actually going to be saved to our local file system. We can see that from our loading data phase, these files have appeared here. Now this notebook is busy executing. And in the meantime, what we can actually do is we can kick off a run that's going to be running on Kubeflow. And we can see here that Elyra takes care of packaging all the nodes and putting all the dependencies together and shipping them off to our Kubeflow cluster and submitting that. So this is just a local Kubeflow cluster, but you can see that that is busy executing at the moment. And if we want to, we can go and have a look at how it's doing, see the logs. I can see that our notebooks have finished executing. So when we're running in local mode, those notebooks are actually updated in place. So if we go ahead and open our flight data notebook, we can see that these cells have actually been filled in here. So this is a typical data processing workflow where we start by reading in the raw data. And this contains a set of records related to flight delays for airports across the US. This is a small sample of the data. We're going to clean up that data to be within a certain date range and to only be related to flights originating from JFK Airport. We allocate some airline names to IDs to make things more human readable. And then we do a bit of column renaming. So there's not actually a lot of pre-processing that happens in this particular data set because it's already pretty clean. But we can see here that we've got things like the flight date, the airline, the origin, destination, the departure time, distance, and of course, the departure delay and whether the flight was actually delayed or not. That's what we're going to be using later to analyze and predict. Similarly, we can open up our weather dataset processing notebook and see that we effectively stepping through very similar steps here. Reading the raw data, cleaning it up. There's a little bit more cleaning that has to happen here. And in particular, we can see that this data set has a categorical feature, which is a set of delimited strings that represents the weather type that is present at that particular weather reading, as well as wind speed, visibility, precipitation, and so on. So there's a bit of cleaning up here and categorical feature extraction that has to happen. And we can see that actually our pipeline is actually finished running in full. So if we have a look here, we can see that each of the notebooks is executed, and we'll be able to work through all of them locally. We also see that the outputs of each node have actually been written into our data subdirectory here. Okay. And then we go through to merging the data, which we simply read in each of the data sets, and we combine this flight delay data with the weather record for the hour previous to that flight. And what we want to do here is try and use some of that weather information to see if we can help predict airline delays. So this is illustrating a very typical piece of the workflow, which is joining two disparate data sets together. Once we've done that, most often we're going to be doing things like trying to train models and analyze data. So this notebook works through analyzing the causes of flight delays and trying to see whether flight delays are linked to or related to in some way for variables such as the day of the week, the departure time of the flight, for example, the airline and or the destination, the distance of the flight, as well as weather. So for example, here we can see this is the proportion of flights delayed when there's drizzle and no drizzle present versus when there's snow or thunderstorms present. And this helps gives us an idea of whether these factors play a role in flight delays. And the final step in our pipeline is to try and build a predictive model. And this is using the same inputs where, again, we're reading the data. We're doing our typical data science steps, such as creating training and test data splits, and creating categorical variables, numerical variables, combining them together, and then performing a model selection process where we're using cross-validation across a few different models with a selected metric to decide which model we're going to be using. And all of this can be accompanied by charts and reports that illustrate cross-validation and evaluation performance. And then at the end, we take the best model and we're going to fit it on our full training set and create a classification report on our test set. Things like ROC curves, precision and recall curves, looking at confusion matrices, as well as feature importances for our tree-based models. So all the typical components of your data science workflow. Now we should see that this particular pipeline is obviously still running. It may take a little while, but previously here we have a pipeline that is executed, and we can see that it follows the exact same DAG that we have here. And we can go to any of these nodes and again take a look at the logs. Now what happens is each of these uploads its results to cloud object storage, or effectively some S3 compatible storage. Here, for example, we see that each notebook as well as the logs is shown. So for example, we can look at our predict flight notebook, and we can actually look at the HTML version of that, which will give us the results similar to what we saw in our local run. We can go down here and get exactly the same output that we had. Okay, so that shows a typical pipeline. What we haven't shown here is obviously model deployment. and some more advanced model tuning. But because we're running on Kubeflow, we can take advantage of some of the components that are part of Kubeflow and Kubeflow pipelines. So for example, we can link into model tuning with Khatib, or we can deploy it to Kubeflow serving once we've trained our model. Okay, so that concludes the demo. So I hope that demo and the presentation have really illustrated some of the power and functionality of Elyra. Elira is still a young project, very active, developing rapidly, and we really welcome community involvement. So please go and give it a try. You can run it locally, you can run it via Docker, you can run it on Binder, you can check out that link, ibm.biz/Elira demo. The notebooks and pipeline definitions for the demo that we've seen today for flight delays are available on GitHub, as well as a set of notebooks running on Elira that illustrate a pipeline for analyzing COVID-19 data that we have developed. We encourage you to join the community and get involved. Come and help us be part of this journey. So thank you very much. Please also encourage you to check out code.org, find us on Twitter, GitHub, developer.ibm.com. Check out the data asset exchange that I mentioned for other interesting data sets. And finally, I know that feedback is super important. So please leave feedback via the online mechanisms for the Data plus AI Summit Europe on the session. Thank you very much.